Hi everyone, welcome to the 14th video of Module 6, and it's now time to test our API that we had developed on the real star data. And the star that we're going to use over here is Betelgeuse, Beta Pictoris, and Sirius A. So let's get started. So quick note over here for everyone is that I have already pushed this kind of changes to our GitHub repository from our previous video. So make sure that you're also doing the same before continuing this video over here. And now it's time to go ahead and test our API that we have created on the real star data that has been taken from Wikipedia and see if it's able to predict this kind of classes correctly or not. So I've already opened all these star data over here in our web browser. And let's see one by one. I'll show you, for example, the Beta Pictoris first of all. What is the value of the absolute magnitude? Over here it is 2.402. So I'll replace this with 2.402. And along with that, we are having the luminosity with respect to the sun is 8.7. So I'll replace this to 8.7. And then we are having the radius with respect to sun, that is 1.8. So radius will be replaced with 1.8. And lastly, we are having the temperature. So temperature over here, if I can see, it is 8052 Kelvin. So 8052. The data for Beta Pictoris is all set. Now let's see what type of star this is. So this is basically the Beta Pictoris system is a very young, only 20 to 26 million years old, although it is already in the main sequence stage of its evolution. So it basically means that it belongs to the main sequence category. Let's go ahead and see if it's going to predict it in a correct way or not. So if I click on execute, it has been executed. And let's see, indeed it is main sequence. And over here, if you notice, main sequence is the highest value. Then the second highest is the red dwarf. Because remember, at the right bottom of the main sequence is where the red dwarf exists. So everything is really cool according to me. Now there's one thing that I would like to change over here is that in the predicted probabilities, I want the output that is starting from the highest probability and then goes down to the smallest probability. So let's see how we can change this up. Now for this, I'll just simply cut this predicted probabilities output over here and paste it over here in a variable called as predicted probabilities is equal to that. Now I'm going to sort this dictionary, that is predicted probabilities, and save it in sorted predicted probabilities. And this is the output that I want over here. So sorted predicted probabilities. Now this is equal to sorted dictionary. Which dictionary? Pred probs. Now if I want to get access of both key and value of this dictionary, I need to write dot items. So with the help of this dot items, I will now have access of all the key value pair in the dictionary in the format of a tuple. And now I want to sort this on the basis of the value. And therefore I'll be giving a key over here, which will be equal to the lambda function that I taught you in one of our previous modules. And it's going to be lambda of item, where I want to have item that is present on index 1. So this item is nothing but a tuple of a key value pair. Now in a key value pair, because value will be present on index 1, key will be present on index 0, I want to have item that is present on index 1, that is value, because I want to sort with respect to the values. And therefore, using this particular line, I will be having the output of the key value pair tuples that will be sorted, which I now need to convert it into a dictionary. So I'll just have dict on top of this. And there is one more thing that I'd like to pass over here, that is reverse is equal to true, so that I start getting the output from the higher value till the lower value. It's going to go in the descending order if I use reverse is equal to true. Now I'll just save this up and go to our application, and I'll simply refresh this up. Now go to the predict endpoint, try it out. click on execute, and this time you can see that now it's in the descending format, starting with the brown dwarf with the highest probability, red dwarf with the second highest probability. That's something that we had seen for our base predicted example that we had seen over here. And now it's time to go ahead and get the data for another star. Over here we are having Betelgeuse, and the temperature is, let's say, 3600. So I'll go to this Swagger UI. Over here I'll click on this temperature one. I'll change this to 3600. And after this we are having luminosity with respect to the sun. Let's just choose it at 90,000. This is 90,000. And then the radius with respect to sun, let's just choose it as 640. I'm choosing the lower bounds. And then the absolute magnitude, it is minus 5.85. Minus 5.85. And now, what is this Betelgeuse? What type of star is this? It's a supergiant, right? So let's see if our model is able to predict it or not. So I'll click on execute. And it predicts indeed a supergiant. The second one that is close is hypergiant. The third one is main sequence. So this is really good. And now last, let's just also check the data with respect to the Sirius star. And specifically over here, we're going to talk about Sirius A star. And if I talk about what type of star this is, so Sirius is a binary star consisting of a main sequence star of spectral type AO or A1, that is termed as Sirius A. So Sirius A is basically your main sequence star. And now let's look into the data of Sirius A. So for Sirius A, the absolute magnitude is 1.43. So over here, I'll just come up over here and just change this data to 1.43. Then what is radius and all this kind of things? I'll scroll down. Over here, we can see that radius is 1.711. 1.711. Then luminosity is 25.4. And temperature is 9940. And now if I execute this, we must get main sequence as the prediction. And there it is. Main sequence is the final output with the highest probability. It is about 80%. And then the second one is very far away as compared to this 80%. So yeah, this is something that we have predicted and it's really good. Alright guys, that was about testing our API on the real star data, and the way it's performing is literally mind-boggling given the fact that we only had 240 rows of data in the whole dataset, in which we again had some training and testing split. So overall, even less data as compared to 240 rows in order to train the pipeline that we had created, through which we finally created this kind of API. That's a really good achievement altogether over here.